Welcome back to my channel. My name is Brian Cafferkey, and this video I'm going to follow up from the previous video I did on dimensional modeling and specifically talk about a really important topic in dimensional modeling and data warehousing called slowly changing dimensions. So let's jump in. There's actually three primary types and then some ancillary types which are sometimes also discussed. Before I get too far, I did want to share with you that I've just published a book called Azure Databricks Step by Step, or I should say Master Azure Databricks Step by Step. If you're not familiar with Databricks, it is a platform that is based on top of Apache Spark. And Apache Spark is the world's most popular open source big data platform. And it also supports data science and machine learning. So it's extremely popular because it can handle any kind of data at any volume. Apache Spark was written by the founders of Databricks, and Databricks is a user-friendly front end around Apache Spark with a lot of other things to speed it up and enhance the product. Now, Azure Databricks is a first-class service that integrates Databricks into the Azure cloud environment. So when I was working at Microsoft, I got so excited about this particular service, I left Microsoft just to write a book about it because I found it was really difficult to get a complete sense and picture of how to use this from end to end. So this is not only a comprehensive resource, but it takes the beginner from the earliest stages, holds you by the hand, walks you through a project step by step to turn you into an expert. And it also uses a step-by-step use case approach. So it says, here's a project, we're going to walk through it. It's also something that I know I'll be referring back to because there's a lot of special nuances, special security methods, etc., that I'm going to need to look back at. How do you do these things? So it's also good for experts. Best of all, it's available on Amazon now, so please go get it, and I look forward to hearing what you thought of it. Where are we going? We're going to talk about what are slowly changing dimensions and how that matters to us. Also talk about types of SCDs. One of the questions you may get, and this is also meant to be kind of an interview question kind of thing, is what are SCDs? Tell me about them. That might be how it's opened up to you. So if you hear SCDs, and this is at all related to data, they should be referring to, but I would confirm, slowly changing dimensions. I did a video, which I'll put at the end of this, the link, and that video talked about dimensional modeling. I'm going to show you what that means, but it basically it establishes something called the star schema. So I'll talk about that because understanding slowly changing dimensions really relates back to dimensional modeling in general. So we'll talk about how would you explain slowly changing dimensions in an interview. I'm going to walk you through the different types so you'll have a good idea what they are. Then we'll wrap things up. Now I want to start by talking about the star schema. Ideally, the star schema is what you want to get to when you're doing a dimensional model. Sometimes in any kind of a modeling, you may have to make some exceptions and variations, but the basic idea is to create a star schema. So let's look at this. In the star schema, we have what they're called, you kind of separate your data into two types, facts and dimensions. Facts are metrics, only metrics, and that's the key. They are numeric and they're quantitative. Sometimes they're also called measures. So an example would be a sales amount, a tax amount, something like how many units were purchased. What is not part of a fact is who bought it, when did they buy it, where did they buy it. A fact is not anything about context. It's just a metric. It's like saying 55. What about 55? Well, 55 is the number of times, I went up the street and where and everything else. That becomes dimensions. So what do I mean by that? Well, in a typical table, in a transactional system, values that describe a transaction, like who bought it, what was the product, etc., are usually included in the same table with the quantity. But in dimensional modeling, you split that out. Things that describe the event are in dimension tables, and those have things that we would normally filter, group, sort, etc. on. How you would slice and dice, the values of that would be what you would call dimensions. But the actual quantities, that's ultimately what people are interested in, how many, how much, that's a fact. All right. So we can see here, for instance, the fact sales table. And all we have in that that's actual information is the sale amount and the tax amount, nothing else. What we have also, if we go to the far left, is the primary key to the table. So that's just a sequence or something. And we have foreign keys that bring us to our dimension table. So cust key is a foreign key that points to the related dim customer, dimension of customer. Prod key points to the dim product table. And so you would use those values to get to the dim product table. Now, an important element to understand also is that when we get data from source systems, they usually have a primary key, right? The CRM system will have a customer identifier. The product system, whatever that is where you make your products, will have product identifiers. In a data warehouse, we don't want to use those. We don't want to make those our primary keys, because if we do, we run the risk of having our whole architecture blown apart because they make a change on their source system. They suddenly decide to reformat their primary key, or merge in a bunch of other data, or just change the keys around. And you might not think it doesn't happen, but I've had it happen. It does. There's lots of things that can happen on the source system, and the BI system is the last thing they're going to think about when they're making production system changes. So by creating your own primary key in your warehouse, dimensions and facts have their own primary keys. And you can see in this, they're called surrogate keys on the dimensions. Now, to locate the related transactions to the right dimension, we will use the source system key. That'll be our lookup value, and we can use that to look it up, but then the foreign key will actually be the surrogate key, which is one we can create and maintain. That way nobody can break it. It's ours. We own it. All right. So what you can see in the fact table, we're pointing to surrogate keys in dim customer and in dim product. So that's the idea of a star schema. No quantitative data that we want to look at, the things that metrics we're looking at, should be in the dimension, and no dimension values should be in your facts sales. Now there are exceptions. There are all kinds of variations on this, but this is the general idea. It's important to understand that, because as I talk about slowly changing dimensions, you're going to need to think about that. So let's walk through what are slowly changing dimensions. Dimension values can change, right? So we have a person in a table, a customer, and this person could get married and their marital status changes. And depending on the business, that could actually have a fairly big impact on their buying patterns, for instance. Or you could have, and this happens a lot, companies reorganize, they change things, they move things around. What had been in this division is moved to that division. Especially in accounting, where they decide to realign things, you suddenly have balances and things moving from one, say, cost center to another cost center or something. So you want to make sure you kind of segregate these things out. The question you need to ask the business is, do you care about these changes? Do they need to be reflected in your reports? A lot of times they do, but it's not the kind of thing the business is typically going to think about. The transaction systems do not maintain historical records of these dimensions changing. They typically just have a code table or a reference table. This is a product list. They're not worrying about all the different deltas, all the changes. This is not GitHub. This is not versioning. But when you're doing reporting, you can't just have something disappear. Suddenly everything was rolling up to one area, and because you just zapped the table, new reports go somewhere else. What will happen is that when people are looking at reports that they had maybe a year ago, maybe they saved a spreadsheet of that data, they're like, why did it move? And if it's something related to sales and people get rewarded by sales, if you suddenly took it away from them and moved it because that's where it currently went to, well, imagine it's a director of sales who gets a commission based on the sales in his district. But you just took that entire, some store in his district and moved it all at once to a new district. But as of last year, that person is entitled to commissions based on the numbers that were there. So these are the kinds of things that you can get into a lot of trouble with reporting. So do you need to reflect these changes? So let's assume this person, Mary, she gets married. And if she gets married, there's the possibility first of her status change, obviously, from single to married, but she may also have, depending on the culture and what she wants to do, a name change. Another example would be something like a store is reassigned to a different region, as I just mentioned. You have a store, let's imagine it's in New York City. And this New York City store had been considered part of the mid-region. That's just the way they organized it in the company. And they decide, really New York City is close enough to Connecticut, Massachusetts, etc. Let's put it in the Northeast region. So it just moved. Now imagine, in that sudden instance, what you just did is took all the historical reporting, all the sales for that store, and it just went from that mid-region to the North region. It has a lot of consequences. That's because there's no reflection. the facts can only point to a single dimension the way it by default, right? So it's going to go, that's what it is currently. And that's how transaction systems typically are. So if you are in a transaction-oriented copy, you just copy their transaction tables, you really don't have a way to deal with this because you're just going to get the latest. So let me walk through that. That actually is type 1. So let's take a look. Type 1 is what I kind of call the do-nothing approach. Do nothing in the sense that typically our dimension tables are just getting truncated and deleted, right? We just delete the product table and refresh it from production, from its transaction system probably every night, or do some sort of ELT process. But basically, if a change comes in, we're going to update it in place. We may truncate and delete, or we may just zap that column. We're going to fix it. So Mary was single, now she's married. So that's what I call very minimalist. It probably is already what you've been doing in your system, so that's what's going to happen. Now the problem is reporting will reflect the current value only. So a year ago, if somebody was aggregating and saying, okay, show me all the sales by, whatever, gender and country, and show me who's single and who's not, single, not single. Well, you just took this person and you just moved him into the married side, but there's no record that a year ago, if you go back and look at historical data from a year ago sales, it's going to show them as married because that's the only value it's got. It's got one row. It's going to show whatever it is at a given point in time. So that's where the data can kind of move around on you. You may not want to do that. The business may care that if they aggregated a year ago, Mary and anyone else who at that time was single would show up in the single column. Again, but if you now just zap it as of today, all the historical data just moved over to the married column if they went from single to married. All right? So the do nothing approach would be, that's okay. Nobody cares. You just zap it. You're good to go. Type 2 is what I call sort of the other extreme. So here we're kind of just updating whatever it is. We've only got one row of dimension data. It's whatever it is, and you just leave it that way. The other approach is sort of the other extreme. We're going to keep a versioning history. So if Mary gets married, we'll keep a row for that. If anything happens, like in this case, she got divorced, it's very sad, but now we have a row for that. So you can see what we're doing in this table, if you can see it here, is that we're actually tracking it. In the first row, Mary was single. And we can see that she first entered our system on May 1st, 2015. She got married, we can see, on 7/12/2017. And that's because we end dated her single record, and then we started a new record starting on the 12th of July, 2017. But apparently she got divorced because we now end dated that 10/15/2019. And we created a new row which starts on that date. But there's no end date. So as far as we know, that's the current status. If you look at the current value, it says no, no, yes. Because the date is null, the end date, this is the latest, greatest. What that means is as new transactions come in, sales for this particular person, for Mary, the new sales will get the latest value, which is she's currently in the status of divorced. But anything that happened between 7/12 and 10/15 would go in the status of married. And anything that happened prior to that would go under the status of single. You're actually going to join each version to separate data because at the point in time when you're loading it and you're matching it to the proper dimension row, that's what it would have been linked to. So let's walk through how this would look. You're inserting a new row, and now look at the fact sales table. What you can see is the key that we're using from dim customer is changing, right? So you can see the cus key. We see in the fact table, it's 2, 3, 4. All of these are just Mary, but they're different versions, so they're under different keys. So you actually have multiple rows for this one person, and you get a new version every time it changes. So this is really just data versioning. And you have to pull out the latest, greatest when new data comes in, and that's fine. You pull out the one that has the flag saying current value Y, or you could even just look at the end date being null. Now, most of the time when this is shown, they don't show this particular approach with a Y flag or the current value flag. They just show the end date you filter for null. But I like the flag because it's a lot easier to read, and I think it's easier for querying and things. Just make sure you don't miss anything in your updates. Okay, that's what's going on here. What's the takeaway? In an interview, what you really just want to make a point of with type 2 is you're keeping version histories of your dimension rows. All right, for when they change, you have the prior, you have the new ones, And when it changes again, you end date the one that was current, so it's not anymore, and you bring a new one in. That's the idea, and your rows of data will relate accordingly. So you're adding a new dimension row. Your reporting will reflect at a point in time, which means your reporting is including historical tracking. Now type 3. Type 3 is to keep a limited history. So here we're kind of trying to get some value of historical tracking, but we don't want to be bothered doing the whole history table thing or versioning. So you just create another column. Here's the current value, and here's what it was in maybe the original or any combination. So you could say I want to track 2, 3, 4 fixed values, but the key thing here is that you're using a separate column to track it. You're not using rows. You're not really versioning. And it makes it kind of awkward for reporting because you're going to have to say which column has the current status, which column has the last status. So I'm not a fan of this approach, and I don't think it's the best way to do it, but maybe there's a use case that does make sense for this. You're keeping a fixed number of historical values, and reporting will reflect some changes, but not all. Now there's other types of slowly changing dimensions. I'm not talking them lightly, and there's a link in the slide. I'll post the link to the Wikipedia site here where you can look at more detail for more information on these. But these other types, which are not your core types, if I were interviewing somebody and they knew what slowly changing dimensions were and at least knew what type 1, 2, and 3 were and could describe it fairly well, I'd be happy. But maybe you're getting someone who really likes all the details and you're going for a data warehousing architecture kind of job, then they may want you to know some of these other types. Type 0 is a strange one because what's happening there is you get one value or set of values for a given dimension and it never changes. You're not updating it, period. So it's a fixed list. In a case like that, you may be just hard coding it. Maybe it's a company code table and you're like, well, we only have 3 companies. We'll just create a code for each one and we're done. Okay. Or maybe it's out of your control. You get values. Maybe you get like a customer table or values from an outside company. You're getting like insurance. Maybe they send you a list of insureds, but it's not your primary. They're not your customers directly. So you don't get any updates. You just get a snapshot when you started. In those cases, that's type 0. You're not going to do anything and you're not even going to get the latest update. You're just going to always report historically what it was when you got the data. Type 4, maintain a separate history table. I have seen this done when I was consulting where the data warehouse was really not modeled at all. They just extracted and joined some tables and created reporting tables, just OLTP, good old LLTP, mixing facts and dimension values together. And then they ran into a problem because their primary keys on their tables were in fact from the source system. They weren't surrogate keys. As a result, they had no way to support multiple versions. So what they did was create a separate table where they did have surrogate keys and then maintained a version history there. They would have to do some sort of external separate reporting because it wasn't part of their typical data warehouse. It was kind of a weird and very awkward thing to maintain, but it was kind of a hook in afterwards. They didn't think of it when they were building the system, and so they had to jury rig something later. And that's one of the things to be careful with. Dimensional modeling is designed to give you the maximum flexibility so that you can adapt for changes. Type 5, separate changing values into what's called a mini dimension. And basically the idea there is you're essentially splitting sort of the parts of the dimension that don't change much from ones that you will get changes for, and then you maintain the changes for the one that does. So it's splitting it out, and the fact table would have to have surrogate keys pointing to both dimensions, and you would typically have the one that's changing more pointing back to the sort of parent dimension. So it's like a parent-child dimension. So you can take a look at that one. I've not seen that in use myself, but something to look at. Finally, there's type 6, which I'm going to show you is a very odd type of thing. Have not seen this one used either. But again, sometimes necessity is the mother of invention. So sometimes it's just a specific use case. And it might be that one person in the whole company says, I really need this, but they're the CEO. You want to give it to them. But you don't necessarily need to make it very flexible because it's not something everyone else is going to be interested in. So this could be a case of that. So here we have a table. They didn't do things right because they have a supplier key, but it looks like they're using probably not a surrogate key, but an actual source system. Because here they're doing row keys, 1, 2, 3, to distinguish. So you'd have to use both of these together in the dimension table to to make sure you have a unique key. Then you have supplier code. Now the thing to point out here is you're doing version tracking, but you're keeping the current state, whatever it is at any given point in time, and the historical state, what it was when this row was created. So if we go to the very end, New York, right? At the current time, it's New York. Historical state, what was it when it was at this point in time in this row? It's still New York because that's when it was created. That started in 2008, February 4th, and it has an end date. It's got this crazy date in the future. It's not done yet. It's current. By the way, a null would be better on end date than doing something like that. You can also see a current flag says, yes, this is the current one. What was it before? Well, if we go backwards, we can see the last row with the date range 2004 to 2008. It was in Illinois, as you can see by the historical value. But the current state's New York, so that just keeps rolling forward. And then you go back one more, and you can see at that time, from 2000 to 2004, December 22nd, it was California. And then New York just keeps cascading through. But that's a hybrid approach, kind of taking 2 and 3. The numbers 1, 2, and 3 add together to 6, so that might help you remember it. But I just think of this as more as being a combination of 2 and 3 because it's doing those 2 different types. So those are ones to keep in mind. Again, I don't think people ask you. Let me know in the comments or something if you come across and said, yeah, they really wanted to know these other types. Then maybe I should do more on these. But dimensional, slowly changing dimensions are a bit of something that hasn't been talked around in a while. I suspect because Snowflake has become so popular, and that's a more traditional kind of relational structure of a way to handle big data. It's getting bigger again. And by the way, Snowflake is oddly named. I don't know, I have to find out why it's named that way, because snowflaking is when you take dimensions and relate them to other dimensions, which is generally considered a bad practice in dimensional modeling. A little tip for you. Good thing for a cocktail party question, right? So wrapping up, what are slowly changing dimensions? We talked about that, and that's when dimension values change, and we need to figure out how do we want to handle that to support reporting. We looked at the types of SCDs. Remember SCDs because if they just say, tell me about SCDs, they're probably trying to fish for the idea, do you know what an SCD means? Slowly changing dimensions, but make sure that's what they mean. We talked about those, and types of SCDs aren't really types, they're actually architectures. There are different ways you would set up and handle a slowly changing dimension to support reporting. So we talked about 1, 2, 3, which are the most important. Type 1, you just update the value in place and don't worry about tracking history. Type 2, you keep a complete record history versioning. And type 3 is you kind of create a couple of columns to try to track, some level of version history. But honestly, it's a bit of a hack. So then we talked about a bunch of others that might come up, and you can take a look at those, and hopefully those are helpful. So we talked about explaining SCDs in an interview, which is really what was the main point of all of this. So I think that's about it. So thank you for watching. Please like, share, subscribe. When you do subscribe, hit the notifications bell so you'll get the latest, greatest updates of my riveting videos. And thank you. And remember, I'm pulling for you. We're all in this together.